Don Fraser with Edge of Space Sciences. My first flight was roughly 24 years ago on EOSS number 4. And for the Colberts over here, my son at the time was about 10 and 12, something like that. And he's still flying balloons on occasion. One of the problems that I've encountered in the numerous flights that I've been trying to chase is that the balloon uses a J-pole, the tracker uses a high-gain vertical antenna, such as this, right? And what's the problem? Both have vertical polarization with the gain going this way, right? And so as you are getting on the flights, the result is that when the balloon is over the tracker, you've got nulls in the pattern that are one over on top of each other. And so basically I would lose the signal. In fact, now as a result, most of the Edge of Space Science guys will start chasing from either the launch point or they'll head right towards the estimated impact point, touchdown point, so that they're actually tracking the balloon from the side of the antenna instead of underneath it. And because that avoids lining the nulls. And as an example, this is the same beacon you saw earlier with the J-pole antenna. You've seen this slide before, showing 4 different tracking vehicles, and you can see all the vertical antennas. Nobody's looking straight up with gain. They're all looking off to the side with gain. And so you see, again, with a vertical antenna, the pattern is left-right. And when you align that with a balloon that's got a pattern to the left-right, it works fine as long as the elevation reference, the tracker, is not very big. But when they get lined up, you have no gain or actually loss here, pointing to loss there, and there's no signal, right? 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 Yeah. Okay, so the solution, use an antenna that has gain in the vertical direction. And what we ended up building was a wavelength loop Yagi that now sits this way. The gain is that way. And when the balloon's overhead, the gain in the vertical direction is greater than the loss from the antenna, and it works. That's a picture of the antenna. This is how big it is. Okay? For 2 meters. It's 80 inches. A meter is 34 inches. So, yes, it's just slightly longer than 2 meters, full wavelength antenna. And the way it works, as we start looking at some of the construction details, this piece here is a transmission line. The coax connector goes here. One side feeds the outside of the loop. The outside feeds one half of the loop. The center conductor feeds the other half. And you end up then getting a nice antenna. It installs on your vehicle fairly easily by fitting into the mount like this, and then a couple of our friendly radiator straps or whatever to hold it in place. And there's a little bit of solder in there just to keep it from rotating too much. But that's I don't know where Dave Klingerman got the mount, the bottom piece. The first, yeah, it could be. I do know that with the one magnet we started with, I couldn't drive over 50 on an asphalt road. And with the 3 magnets, I can now do at least 65, which is the speed limit on some of the gravel roads in rural Colorado. And it stayed on top of the car. 64, yeah. I hope there's nothing magnetic close to that. So, that's it. Again, showing some of the construction details, a picture of the feed point, where the coax, there's a piece of insulation there, okay? And this is where the coax connector attaches. So the other half of the loop is a low impedance point and is attached then to the outside of the pipe for rigidity, and the center feed feeds all the way through then to over here. Yes?
What are you using for your insulator?
It's plastic of some kind. Dave Klingerman is Old Antenna Labs out of Denver or Parker, and he's made a number of antennas up into the multi-tens of gigahertz for the high-frequency guys up there in the Denver area. And he's got a few loop antennas that he sells for, or halos, for the 2-meter AM crowd. And he adapted the 2-meter halo design to this practice, but the gain is going up instead of out. So theoretical gain of a 2-element conventional Yagi is about 5 dBi. With experience, they show they get about 2 more than that. So we should see about 7 dB of gain in the vertical direction, which this is doing 7 dB of gain in the horizontal direction. And it equates to about 45 degrees of bore sight. So the testing of this antenna was use it to actually track, and then do some theoretical studies, or actual studies measuring the pattern and the frequency profile in the lab. What I did on the 2 launches of 194 and 195, I positioned the vehicle underneath the projected burst point and tried to see how much of the flight I could capture with first the vertical antenna and then the new antenna. And the transition point was about 35,000 feet. And I don't know how well you can see this, but I was roughly right about here on Colorado 74. And a couple of other road intersections in that area, and it worked just fine. I could listen to it using the vertical antenna as it was coming up. As it crossed 35,000 feet, I lost it in the vertical antenna. It was about 13 miles away from me, and I maintained contact with it using the new antenna almost all the way back down to the ground. But as it was coming down on the ground, I was moving east, so I was getting closer, and it didn't make any difference that the gain was in the wrong direction. I was able to capture or decode APRS during the post-burst chaos when the antenna's doing, swinging left and right, up and down. And normally we don't capture a whole lot of anything, but because of where I was and the gain in the antenna, it worked to capture and decode the message. So the summary is, as I went, again, 13 miles away, I would end up getting 1 or 2 bars on my Kenwood, and then I switched over to the antenna, and it went back to full scale, and I started decoding everything through the rest of the flight. So yes, the antenna works. It provides, like for Zach, a way to stay under the balloon as you're heading downwind with the balloon, and keep track of what's going on. Looking at the patterns, this was when we went to the test site. This was my transmit array. This was how we set it up to receive. Ray Ubrecken and a compatriot of his, where we did the testing, some of the test equipment. when we started looking at how that board was laid out, it's just a 4x6 sheet of plywood, roughly equating to the roof of a car, and it's got a little bit longer dimension that's 6 feet left to right and 4 feet up and down. And so when you look at the table here, the vertical direction is with the board standing vertically, and the horizontal is with the board like it was there on the ground. And you can see what the numbers are. It equates to a pattern looking front to back like that, and a pattern left to right that looks like that. So it's actually sharper than the 45 degrees, the 3 dB point. So the gain is even greater than 7 dB. Frequency plot by one set of instruments. You can see how it's kind of tuned for the upper part of the 2-meter band. When you look at it here, it's pretty flat from 144 to 148. I looked at it again using a Rig Expert AA600. Yes, the SWR is pretty high of 3 to 1, but you don't transmit too much. You can transmit through it, and I did, but 50 watts going in with 3 to 1 SWR, you're still putting a lot of power into the towards the balloon when it's only transmitting 300 milliwatts, and you're able to receive it. So it will digipede through the balloon if need be. And here's the same antenna, though it's designed for 2 meters, it resonates well enough at 450 because it's a third harmonic. So conclusion is, if you need something to stay under the balloon, try it. I had some help from W6OAL, some help from EOSS, and AA0L in the testing. Any other questions? Yes?
Can you talk about the feed point? You have the coax connectors on one side, and
yes.
The actual feed is on the opposite?
Yes.
So is it grounded at
yes.
this point here?
The whole antenna is a DC ground.
Okay.
So.
And then you said the center conductor going through?
The center conductor goes all the way through and attaches to the outside right there. So the center feeds this one, and the shield feeds that one. And it's a low impedance point then back here at the shield. So.
Hey, Don?
Yes?
Have you compared that to Chris Kringle's method of just tipping his car over on 2 wheels?
I tried that, but not tipping the car. I have the Comet B10. I've tried this over the years. I've tried this antenna like that.
How does that work?
It didn't. It didn't help any. It's too pointed. Too narrow. Whatever. It didn't work either. So. Yeah. Well, I contacted Dave earlier this year, and we started talking back and forth. And so, in reality, this whole effort, this prototype was built between early March of this year and was then in the early May, mid-May, was it, flight 194, 195? April. So in 6 weeks, we kind of put the antenna together and tested it a couple of times. Yes?
Your mount there, is that a quarter wave above your roof?
Yes. It's not adjustable, but it's roughly 2/10 of a wavelength, not a quarter wave. Yeah.
Do you have dimensions posted for that anywhere?
Yes, they're in the slide.
Oh, where that
Let's see, a couple more. That's the dimension for the loop itself. And the loop is located about 15 inches above the car, or about 0.2 lambda. Now, Dave, like a number of us, is retired. He said he would build some, but reluctantly. And the price that he's quoted me is, reflects that. Yeah, not quite go away, but he said about $400 would get you one if you wanted it. And that includes shipping.
He's the one that builds the wheel antennas?
Yes, yeah.
Old antenna labs or whatever.
Yeah, Old Antenna Labs out of Denver. So anyway, yes. But if there are people that are interested, maybe we can get some kind of bulk purchase, or at least some of the parts from Dave, like the flat steel or flat aluminum, and bend it, and then do some of the construction material, construction ourselves. Yes?
Another good antenna for that is the old turnstile with two dipoles, 90 degrees out of phase, placed a quarter away from the road. Now it can be about
It's the same kind of, yeah. The whole idea is if you can get 5 to 10 dB of gain going up, you're going to be able to copy the antenna when it's over you, copy the balloon, than if you're trying to use one of these.
That's only good if you're a good tracker. You get underneath.
Well, or you do like I did, is ended up given the estimation programs that we have.
Head for the destination.
I head for the, a lot of the folks would head for the destination. I like to start in the middle and just follow it because I'm driving usually a lot further than some of them. I live in Colorado Springs and they're flying out of Windsor or something like that. So it's 100, 150 miles just for me to get to the assembly point. And
Short trip.
yeah, short trip. Round trip can be, a flight can be over 300 miles for me. And I avoid those where it's predicted to land in Sterling or almost western Nebraska, because it becomes a long day at that point. Other questions?
So,
Yeah.
did you do any analysis of any packet loss adverse? I mean, did you see, were they coming down every 30 seconds?
Yeah. I mean, every time the radio beeped, I'd see a decoded packet. And I mean, I was watching the S meter and things like that, so I would see every 30 seconds.
That would be good to have a mobile eye gauge.
Exactly.
That antenna right underneath the balloon.
Yes. Yes.
Because like inevitably with the vertical, it's swinging along and
Yeah.
it goes out of phase and you lose a packet. You might hear most of it, but
Yeah.
it just doesn't decode. So,
I think my next project's going to be the Raspberry Pi and 2 TNCs to do a little mobile eye gate with parts to display it. Okay?